Part 5. Commissioning the equipment. Chapter 1. Commissioning an NE. 1. Powering on the equipment. Before powering on the equipment, ensure that the following requirements are met. 1. The equipment hardware installation has been completed and has passed the installation check. 2. The input power is available. 3. The input power has been turned off. 4. The system power and ODU power switches on the PXC and IF boards respectively are turned to O, which means off. Connect a multimeter at the input power supply, for example, the output terminal of the cabinet power distribution box, to test the voltage and polarity of the input power. When the nominal voltage of the input power is negative 48 voltage, the test voltage should be negative 57.6 to negative 38.4 voltage. When the nominal voltage of the input power is negative 60 voltage, the test voltage should be negative 72 to negative 48 voltage. Then turn on the input power. Set the system power switch on the PXC board to I. Set the ODU power switch on the IF board to I, that is, close the circuit. The equipment needs 3 to 5 minutes to fully start. 2. Logging into the NE and modifying the NE ID. After the equipment is normally started, start the web LCT for configuring the equipment. Note: the LM system used for demonstration in this course is web LCT V2R4CO2B019. The actual commissioning depends on the version of the MM system you use. Use a network cable to connect the network port of the computer to the NM port of the optics RTM600. Set the IP address of the computer. The IP address of the computer is in the 129.9.0.0 network session. The subnet mask is 255.255.0.0. For example, 129.9.0.12. Double-click the Web LCT icon on the desktop to display the Web LCT interface. The default username is admin, and the password is T2000. Click Login to enter NE list. Click NE Search, and the Search NE dialog box is displayed. The default domain is 129.9.255.255. Click the Search NE button to start searching NEs in the default network section. After the NEs are searched, click End Search. Then click the Add NE button. A dialog box is displayed indicating that the operation is successful and confirms if you want to log in to the NE. Click OK. Click Cancel in the Search NE dialog box. The added NEs are listed in NE list. Click the NE you are going to log into. Then click the NE Login button. The NE Login dialog box is displayed. Enter the default username, which is root, and the password, which is password. Click OK to log into the NE, and you can view the information of NE ID, NE name, equipment type, alarm status, gateway type, gateway IP address, communication status, and login status. Then click NE Explorer or double-click the NE in NE list to enter the NE Explorer interface. Select the NE from the object tree. Choose Configuration NE attribute from the function tree. Refer to the network planning and modify the NE name and NE ID. It is recommended that you add the NE ID before the NE name. Click Apply to modify the NE name. Then, click Modify NE ID and enter the NE ID specified in the network planning. Click OK. A dialog box confirms if you want to make the modification. Click Yes. The NE is reset. Close the NE Explorer and remove the NE from the NE list. After the NE is reset, search and add it again. Note that the name and ID of the NE have been modified. Then log into the NE. Open the NE Explorer. 3. Quick configuration. Note: 1. Quick configuration clears all the configuration data at the NE side. This operation is applicable to the initial installation and commissioning only. 2. Quick configuration is applicable to PDH microwave. Ensure that all boards are online. When the service board contains line boards or more than 2 IF boards, quick configuration is not supported. 3. The following operations are carried out on a 1+0 non-protection system. For a 1+1 protection system, you need to configure the IF 1+1 protection before you configure IF attributes. Display the NE Explorer. Select the NE from the object tree. Choose Configuration, Quick Configuration from the function tree. The Quick Configuration dialog box is displayed. A dialog box confirms the operation, and click Next. The dialog box confirms the operation again, and click Next. The NE Panel dialog box is displayed. Confirm the board configuration and click Next. Referring to the microwave design, set the parameters of the IF attributes. Click Next. Select the time slots as planned. Click Next. Click Clock Configuration and enter the clock configuration data as planned. Then, click Configure AutoWire and enter the AutoWire phone number as planned. Click Next. Confirm the correctness of the configuration data and click Next. Click Apply. The Web LCT automatically issues all of configuration data to the NE side. Click Close and the configuration is completed. Select the NE from the object tree. Choose Configuration, NE Time Synchronization from the function tree. In the display dialog box, set Synchronous Mode to NM. Click Apply. Select the NE from the object tree. Choose Configuration, Alarm, Alarm Suppression from the function tree. You can select Suppressed or Not Suppressed to suppress or not suppress certain alarms. Click Apply. To restore the alarm suppression to the initial configuration, click Default and then click Apply. Select the NE from the object tree. Choose Configuration, Performance, NE Performance, Monitor Time. In the NE Performance Monitor Time tab, select the NE that you want to set. Select Enable for a 15-minute performance monitor and 24-hour performance monitor. Click Apply. 4. General Configuration. Log into the NE and display the NE Explorer. Add the PXC board first and then add other boards. You need to add boards first. Right-click the slot and add a board. After all the required boards have been added, select the NE in the object tree. Choose Configuration, IF 1+1 Protection in the function tree. Click New to open the Create IF 1+1 Protection dialog box. Set the parameters according to the network planning. Take HSB protection as an example. The protection group number is 1. When the equipment is configured with 2 IF 1+ protection groups, the protection group number can be modified. Click the Working Mode drop-down list and you can choose SD, FD, or HSB. Select HSB in this case. You can choose revertive or non-revertive in the revertive mode drop-down list. The WTR time is 600 seconds by default. You can modify the WTR time based on the network planning. By default, the reverse switching is set to Enable. According to the network planning, select the IF board in slot 5 as the working board and the IF board in slot 7 as the protection board. Click OK. Then, in the IF 1+1 Protection tab, the created IF 1+1 protection is displayed. The upper protection group pane shows the protection groups, and the lower slot mapping relation pane shows the mapping relation between slots. Relative attributes are displayed in the pane. Select the main IF board in slot 5 from the object tree. Choose Configuration, IF Interface from the function tree. In the IF Attribute tab, double-click Radio Work Mode and select the mode as planned. Modify Radio Link ID. Click Apply. Then click Query to check if the setting is successful. ATPC is disabled by default. Select the main ODU in slot 15 from the object tree. Choose Configuration ODU Interface from the function tree. In the Radio Frequency Attributes tab, double-click Transmit Frequency and enter the transmit frequency as planned. Select whether to set TR spacing based on the microwave design. Click Apply, then click Query to check if the setting is successful. click the Power Attributes tab, double-click Transmit Power and enter the transmit power as planned. Click Apply. Click the Advanced Attributes tab, double-click Configure Transmission Status and select Unmute. Click Apply, then click Query to check if the setting is successful. Select the Standby ODU in slot 17 from the object tree. Choose Configuration, ODU Interface from the function tree. Click the Advanced Attributes tab. Set Configure Transmission Status to Unmute. But as the ODU is the standby ODU, the actual transmission status is still mute. Select the NE from the object tree. Choose Configuration, Auto Wire from the function tree. Enter the planned telephone number in telephone number. Select the auto wire port. Click Apply. Select any time synchronization from the function tree. In the display dialog box, set synchronous mode to NM. Click Apply. Select the NE from the object tree. Choose Configuration, Cross-Connection Configuration from the function tree. Click New. The Create SDH Service tab is displayed. Referring to the network design, set the parameters. Select the planned service level in the level drop-down list. Select VC12 in this case. Select Bidirectional in the direction drop-down list. Select the PH1 board in slot 8 in the source drop-down list. Enter 1 to 4 in the source time slot range field. Select the IF board in slot 5 in the sync drop-down list. Adopt the default values for sync port and sync VC4. Enter 1 to 4 in the sync time slot range field. Click OK. You can check the attributes of the created service in the Cross-Connection Configuration tab. You can click Create SNCP in the Cross-Connection Configuration tab to create the SNCP service. In the Create SNCP Service dialog box, configure the parameters as planned. The attributes you need to set include service type, level, relative mode, direction, hold-off time, and WTR time. Then set source, source port, source VC4, and source time slot range, respectively, for the working service and protection service. Finally, set sync, sync port, sync VC4, and sync time slot range. Click OK. You can check the attributes of the created SNCP service in the Cross-Connection Configuration tab. Select the NE from the object tree. Choose Configuration, Clock, Clock Source Priority. Click Create. The Add Clock Source dialog box is displayed. Referring to the network planning, select the clock source to be added. Click OK. You can change the clock priority level by selecting the clock source and clicking the up and down button. Click Apply. Choose Configuration, Clock Subnet Configuration from the function tree. In the Clock Subnet tab, set Affiliated Subnet and Protection Status as planned. Click Apply. Also referring to the network planning, set Clock Quality, SSM Output Control, and Clock ID status. Following the method introduced in the Quick Configuration, adjust the Alarm Management function. Enable 15-minute Performance Monitor and 24-hour Performance Monitor. For detailed service configuration, refer to the Optics RTN 600 Radio Transmission System Configuration Guide. 5. Relevant Test Interfaces. 1. E1 Loopback. Select the PDH interface board from the object tree. Choose Configuration, PDH interface from the function tree. Set the loopback status of the path as required. You can select non-loopback, in-loop, or out-loop. Click Apply. Click Query, and you can check if the setting is successful. 2. Transmit frequency and transmit power. Select the ODU for which you want to query the transmit power from the object tree. Choose Configuration, ODU interface from the function tree. Select the Radio Frequency Attributes tab and the Power Attributes tab. Click Query. The actual transmit frequency and actual transmit power are displayed. The actual values should be the same as the preset values. If the actual values are different from the preset values, record the type and the sequence number of the ODU and contact Huawei engineers at the local office. 3. Transmit, receive optical power. From the object tree, select the optical interface board for which you want to query the optical power. Choose Performance, Current Performance from the function tree. Set the options for querying the optical power performance. Monitored object filter condition, all. Monitor period, 15 minutes. Gauge, launched optical power and received optical power. Display options, maximum minimum value. Count, do not select any item. Click Query. Browse the optical power performance in the window. After you complete the any commissioning on the two ends of a hop of a microwave link, you can start the hop commissioning, including aligning antennas. Chapter 2. Hop Commissioning. 1. Aligning the antennas. The tools and instruments you need for aligning antennas are BNC cables, digital multimeter, and wrench. The following operation considers align 0.6 meters antennas as an example. When the antenna is of a different diameter, please refer to the relevant document. Note: before aligning the antennas, ensure that the ATPC function at the two microwave stations is disabled in order to maintain a fixed transmit power of the antenna during the commissioning. When the distance between the two stations is long, more than 2 kilometers, you need to place the antennas horizontally in the beginning. When the distance is short, you need to finally adjust the elevation angles of the antennas according to the actual situation. How to align the antennas? 1. Use the BNC cable to connect the multimeter to the RSSI port of the ODU. If there is no BNC cable, you can connect the multimeter directly to the RSSI port of the ODU. 2. Adjust the azimuth angle of the antenna. Keep the remote antenna fixed. Loosen the nuts on the horizontal adjustment bolt of the local antenna. Rotate the antenna around the pole. Usually, when you rotate the antenna, 3 peak signals can be obtained. The middle peak signal has the highest voltage. 3. Adjust the elevation angle of the antenna. Properly loosen top and bottom connection bolts between the antenna and the mounting bracket. Rotate the elevation adjusting bolts to adjust the antenna elevation. The range is -15 degrees to +15 degrees. In the 3 directions where the 3 peak signals appear, adjust the elevation angle of the antenna until the 3 receive levels reach their respective maximum values. Then adjust the antenna to the position where the receive level is the highest of the 3. Tighten the antenna. When you tighten the antenna, ensure that the receive level remains at the maximum value. 4. Refer to steps 2 and 3 and adjust the remote antenna. When the remote receive level reaches the maximum value, tighten the remote antenna. Repeat steps 2 to 4 to make the receive levels at the local end and the remote end reach the planned value. Tighten the antennas at the two ends. During the tightening, ensure that the receive level is at the maximum. Use the multimeter to test the receive level values at the two ends. Refer to the receive level values and the received signal level curves of the ODUs at the two ends and read the current receive power values. The actual receive power should be the same as the planned value. The difference should range from -3 dBm to +3 dBm. Note: for a 1+1 protection system, it is suggested that you turn off the power of the standby ODU before you adjust the antenna. 2. Relevant test interface. 1. Testing the ECC. Log into the web LCT and start searching NEs. If the ECC is normal, the web LCT can search the local NE and the remote NE. To add NEs, you can hold down the control key and use the mouse to select multiple NEs you want. Click NE Login. Select the Use Same Username and Password to Login checkbox. Enter the username and the password. Click OK. If the login status of the two NEs displays logged in, the ECC test is successful. 2. Testing the auto wire phone. Dial the auto wire phone of the opposite station. If the call is successful and the conversation quality is good, the auto wire phone test is successful. 3. Testing the IF 1+1 protection. Select the NE from the object tree. Choose Configuration, IF 1+1 protection from the function tree. Make sure that the status of the IF 1+1 protection is normal. That is, make sure that the IF board in slot 5 is the working board at the equipment side. Turn off the power of the main ODU and check the switching status. If the IF board in slot 7 is displayed in the active board of device fields, the switching is successful. To test the IF 1+1 protection switching, you can also right-click Working Board or Protection Board in the slot mapping relation pane and select Forced Switch to Working or Forced Switch to Protection. After the test is completed, clear the protection switching. 4. Looping back the optical interface. Select the optical interface board on which you want to perform the loopback operation from the object tree. Choose Configuration, SDH interface from the function tree. Select By Function and select the required loopback mode from the drop-down list. Click Apply. You can click Query to view the setting result. The optical interface loopback is automatically released 5 minutes later. You can select the NE from the object tree and choose Configuration, Automatic Disabling of NE function from the function tree. In the Automatic Disabling of NE function tab, you can set auto-disabling and auto-disabling time of the loopback. Click Apply. Note: Optical interface loopback is an operation with possible dangers. It must be carefully implemented by a qualified engineer under an authorized permission. 5. Testing the PRBS. Select the tributary board you want to test from the object tree. Choose Configuration, PRBS Test from the function tree. In the PRBS Test tab, select the port you want to test and set direction, duration, measured in time, and accumulating mode. Click Start to test. The system displays a dialog box confirming the operation. Click Yes. The value of the bit errors generated during the test is displayed in the total PRBS field. 6. Querying the software version. Select the NE from the object tree. Choose Report, Board Information List, Board Information Report from the function tree. The Board Information Report interface is displayed. Click Query. You can view the software version and other board information. 7. Querying alarms. Select the NE from the object tree. Choose Alarm, Alarm Browse from the function tree. There are 2 tabs named Browse Current Alarms and Browse History Alarms for you to view current alarms and history alarms on the NE respectively. By default, the Browse Current Alarms tab is open. Click Filters and set the required filtering conditions. Then, you can view only the alarms that you want. Click Save As to save the current alarms to a file. Click the Browse History Alarms tab to view, query, or save the history alarms. 8. Querying performance events. Select the board for which you want to view the performance events from the object tree. Choose Performance, Current Performance, History Performance from the function tree. Set the parameters to view the current or history performance events on the board. 9. Querying abnormal events. Select the NE from the object tree. Choose Alarm, Browse Abnormal Event from the function tree to view the abnormal events on the NE. Click Filter and set the required filtering conditions. Then, you can view only the abnormal events that you want to view. After the commissioning, ensure that the following requirements are met. 1. The NE ID complies with the network planning. 2. The NE time is synchronous with the NM time. 3. The board status is normal. 4. The software version is correct. 5. The clock priority level is set as planned. 6. The current alarms have rational reasons. 7. The cross-connection, IF 1+1 protection, and board 1+1 protection are configured as planned. 8. The IF board and ODU are configured as planned. Make sure that the equipment operates normally and all the items to be checked comply with the network planning. That's all for this course. Thanks for your attention. Part 4. Installing the IDU. Note: Electronic circuits and components are extremely sensitive to electrostatic discharge. Before installing the IDU, ensure that you wear anti-static gloves or anti-static wrist strap. 1. Installing the IDU. Confirm the position where the IDU is going to be installed. Take out the IDU from the anti-static bag. Check if the name and code of the IDU are the same as those identified on the packing box. Check if the IDU is intact. To facilitate the installation, you can first install the protection grounding cable to the IDU. Pay attention that the cable should be installed in the same direction as the later cabling direction. Then, secure the screws. Fit the IDU in the expected position of the cabinet and fix the IDU by securing the screws. Note that the IDU must be horizontally installed in the cabinet. For other methods of installing the IDU, refer to the Optics RTN 600 Radio Transmission System Installation Guide. 2. Installing the protection grounding cable. Determine and create the length of the grounding cable based on the position of the grounding bar. Based on the type of the OT terminal, strip a certain length of the insulating layer off the grounding cable and expose the conductor. Cover conductor with the OT terminal. Keep the cross-section of the conductor level with the end face of the OT terminal. Use crimping pliers to compress the terminal to ensure a reliable connection. Finally, properly fasten the protection grounding cable to the grounding bar and tighten the nut. 3. Installing the power cable. The nominal power voltage of the Optics RTN 600 product is negative 48 voltage or negative 60 voltage DC. The voltage of the working power ranges from negative 57.6 voltage to negative 38.4 voltage or negative 72 voltage to negative 48 voltage. When the IDU 600 is fully configured, the nominal current is 4 ampere. When the IDU 620 is fully configured, the nominal current is 8 ampere. Precautions for installing the power cable are as follows. 1. Do not install or remove the power cable with the power on. Before installing or removing the power cable, turn off the power to prevent body injury or equipment damage. 2. Check the DC power distribution box and confirm the cable connections. The blue cable connects to the negative 48 voltage power. Part 2. Installing the antenna. Caution: outdoor installation of microwave equipment involves working at heights. Ensure the safety of engineers. Chapter 1. Preparations for installation. Limited by manufacturing and transportation, large-size antennas are disassembled for the convenience of delivery. When goods arrive, you need to assemble the antennas by following the instructions provided along with the goods. Small-size antennas don't need to be assembled. Before hoisting the antenna, confirm the height at which the antenna should be installed. Use the compass or GPS to check the azimuth of the antenna. Also verify that the type and polarization direction of the antenna is compliant with the network design. How to adjust the polarization direction of the antenna. By default, the antenna is set to vertical polarization. The polarization identification point on the feeder should be aligned with the V mark. If the polarization direction need to be changed, loosen the screws that are used to fasten the feeder and rotate the feeder 90 degrees so that the polarization identification point is aligned with the H mark. Stop rotating the feeder and fasten the screws on the feeder. You can also judge the polarization direction of the antenna by observing the waveguide of the feeder. If the short side of the rectangular waveguide is vertical to the ground surface, the antenna is vertically polarized. If it is parallel to the ground surface, the antenna is horizontally polarized. Chapter 2. Hoisting the antenna. Caution: ensure no people below the iron tower when installing and commissioning outdoor equipment. Thread the hoisting rope through the hoist rings on the antenna and tightly knot the rope. Bind the pulling rope to the hoisting rope. For a large-size antenna, 2 pulling ropes are required. The 2 pulling ropes are bound to different points of the hoisting rope to prevent the antenna from rotating when it is being hoisted. The hoisting rope is used to hoist the antenna. The pulling rope is used to pull the antenna to prevent it from colliding with the iron tower. Small size antennas can be easily hoisted to the top of the iron tower by 2 persons. The installation and fastening is much simpler. For large size antennas, however, pulleys need to be installed on the top of the iron tower. Then the antennas can be hoisted to the top of the iron tower by using a machine or by manpower. After the antenna is securely placed on the top of the iron tower, properly fix the anti-fall bracket to the pole. The anti-fall bracket is used to support the antenna to prevent it from falling during adjustment. Spread anti-seize grease on the 4 bolts of the antenna. Fix the antenna to the pole. During the fixing, do not remove the hoisting rope from the antenna. Instead, bind it to the iron tower tightly to prevent the antenna from falling. Ensure that the hoisting rope is not removed until the antenna is firmly fixed to the pole. In this process, note the azimuth of the antenna. After the antenna installation is completed, remove the 2 rubber plugs at the bottom of the antenna shield. Then, you can hoist the hybrid coupler and ODUs, which is similar to hoisting the antenna. The pulling rope is required during the hoisting to prevent the hybrid coupler and the ODUs from colliding with the iron tower. Note: antennas, hybrid couplers, and ODUs must be hoisted separately. Hybrid couplers and ODUs must be separately installed after the antenna installation. Huawei Technologies. Optics RTN600 Radio Transmission System, Hardware Installation and Commissioning. The Optics RTN600 Radio Transmission System Hardware Installation and Commissioning is an auxiliary teaching material describing the methods for installing and commissioning Huawei Optics RTN600 series microwave product hardware, with photographs illustrating methods and precautions for the engineering. It is for reference only. On-site installation depends on the actual engineering implementation. This material is divided into 5 parts. Part 1, Engineering Preparations and Unpacking Check. Part 2, Installing the Antenna. Part 3, Installing the ODU and IF cable. Part 4, Installing the IDU. Part 5, Commissioning the equipment. Part 1, Engineering Preparations and Unpacking Check. Chapter 1, Engineering Preparations. 1. About the equipment. The Optics RTN600 radio transmission system is a line-of-sight digital microwave transmission system developed by Huawei Technologies. Each radio frequency carrier of the Optics RTN600 can transmit 4 or 8 or 16 E1 or 1 STM1. An RTN600 microwave radio transmission system consists of 3 parts. They are IDU, ODU, and antenna. The IDU is the indoor unit of the Optics RTN600. The IDU accesses services and performs multiplexing, demultiplexing, and IF processing of the services. The IDU is of 2 types, IDU 610 and IDU 620, at a height of 1 unit and 2 unit, respectively. Either IDU 610 or IDU 620 can be installed in a 19-inch cabinet, in an ETSI cabinet, on a wall, or on top of a table. IF cables, SDH, PDH signal cables, power cables, alarm cables, and order wire cables are all let out from the front panel of boards. The ODU is the outdoor unit of the Optics RTN600. The ODU performs frequency conversion and amplification of radio frequency signals. Antennas are used to focus the radio frequency signal transmitted from the ODU to increase the signal gain. The gain depends on the diameter of the antenna and the frequency. 2. Preparations for engineering installation. To ensure that the installation is performed smoothly, engineers should carefully read all the related documents and ensure that all the required installation tools and instruments are available. 2 categories of documents are required: engineering design and installation guide. Engineering design documents include network plan and engineering design. Installation guide documents include Optics RTN 600 Radio Transmission System Installation Guide and Optics RTN 600 Radio Transmission System Commissioning Guide. The required tools are as follows. Hoisting tools include 100-meter hoisting rope, pulley, and safety belt. Drilling tools include percussion drill and accessory drill bits. Fixing tools include cross-tip screwdriver, flat-tip screwdriver, solid wrench, adjustable wrench, socket wrench, and hex key wrench. Bench work tools include sharp nose pliers, snap-off knife, and diagonal pliers. Auxiliary tools, multimeter, electric iron, cable peeler, crimping pliers, crystal connector crimping pliers, solder wire, wire punch-down tool, brush, and nippers. In addition, you also need to prepare laptop, compass, GPS, 50-meter tape, measuring tape, and marker. 3. Checking installation conditions. Before installation, engineers should check the on-site installation conditions according to the Microwave Equipment Installation Environment Checklist. The items to be checked are as follows. 1. Installation position of the IDU. 2. Indoor grounding point. 3. DC power availability. 4. Environment temperature. 5. Installation position of the antenna. Chapter 2. Unpacking check. First, check the following items according to the packing labels on the packing boxes. 1. The total number of goods is correct. 2. The appearance of the packing boxes is nice. 3. The delivery destination is correct. Note: during unpacking, representatives from the customer, the contractor, and Huawei must be present. Unpacking is not allowed if any of the three parties are absent. The customer may not be present if authorization is granted by the customer. The packing list is enclosed in the packing box marked with a red label. The engineering supervisor and the customer representative should check the quantity of goods, item by item, according to the packing list. The check must be thorough and complete one time and must be finished before the installation. Check the installation-related material. Use a snap-off knife to cut the adhesive tape on the cartons. According to the packing list, check the quantity of alarm cables, fiber jumpers, power cables, grounding cables, cable ties, and adhesive waterproof tape. Fill the actual quantity of each item in the packing list. Do not just tick or write OK. Check the IDUs and boards. Check the appearance of the IDUs. Verify that the boards and installation accessories are complete. Check the hybrid couplers. According to the packing list, verify that the hybrid coupler accessories such as tools, documents, and polarizers are available as required. Verify that the appearance of the hybrid couplers is intact, and also verify that the frequency information of the hybrid couplers is correct according to the design documents. Check the ODUs. Check the appearance of the ODUs. Verify that the frequency information of the ODUs is correct according to the design documents. Check the antennas. Check if the appearance of the packing crates that contain antennas is nice and intact. Insert the sharp end of the flat-tip screwdriver into the hole of the tongue and straighten the tongue. After straightening all the tongues on the crate cover, remove the cover. Verify that the appearance of the antenna is intact and the installation accessories are complete. Verify that the frequency information of the antennas is compliant with the design documents. Note the following points when unpacking the crates. 1. Do not insert the crowbar into the crate when unpacking, otherwise you may damage the antenna inside. 2. The crate must be placed upright to avoid damaging the antenna inside. 3. Avoid any pressure against the reflective surface when moving and laying down the antenna. After the unpacking check, the engineering supervisor and the customer representative shall confirm the result by signing the packing lists. Both the parties should keep a copy of the packing lists. During unpacking, if any goods are found short in number, of the wrong type, deficient, over-delivered, or damaged, Write down the packing list number and take a photo of it. The project supervisor should fill in the equipment problem report and send it to the local office of Huawei. Please pay attention to the following precautions during the engineering. 1. Strictly observe the ESD control specifications. Make sure that you wear a securely grounded anti-static wrist strap or a pair of gloves when you touch any metallic parts on circuit boards or equipment. Do not touch any electronic components on boards with bare hands. 2. Wait for at least 30 minutes before unpacking. If the equipment has been moved from a cold and dry place to a warm and damp place. Otherwise, moisture that accumulates on the surface of the circuit board can damage the components. Part 3. Installing the ODUs and IF cables. Chapter 1. Installing the ODU for a 1+0 non-protection system. Note: this photograph was taken on the ground and is for demonstration only. In a 1+0 non-protection system, the ODU is directly mounted on the back of the antenna. Before the installation, ensure that the polarization direction of the antenna and the type of the ODU are compliant with the design. Remove the protective cap from the antenna feeder. Apply appropriate lubricant to the gasket of the feeder. Ensure that the polarization direction of the ODU is the same as that of the antenna. Slowly feed the antenna interface of the ODU into the antenna feeder until the 4 latches on the ODU engage with the 4 hooks on the antenna. Close the 4 latches cornerwise, and the installation is completed. Chapter 2. Installing the hybrid coupler for a 1+1 protection system. First, verify that the type of the hybrid coupler is compliant with the design. By default, the antenna interface of the hybrid coupler adopts vertical polarization, but if the antenna adopts horizontal polarization, ensure that the polarization direction of the antenna interface of the hybrid coupler is the same as that of the antenna. How to change the polarization direction of the hybrid coupler? Use the hex key wrench to loosen the screws to fasten the polarization part in the antenna interface of the hybrid coupler and remove the polarization part. Then replace the vertical polarization converter with the horizontal polarizer. Fix the polarization part into the antenna interface of the hybrid coupler. Ensure that the arrow indicator on the polarization part points in the horizontal direction. Fasten the polarization part by using the screws. Note: store the horizontal polarizer or the removed polarization converter in a proper manner. After the hybrid coupler is hoisted to the designated place, apply an appropriate rust-proof lubricant to the captive screws on the hybrid coupler to prevent the captive screws from being fixed so tight that they cannot be loosened during maintenance. Remove the protective cap from the antenna feeder. Apply an appropriate lubricant to the gasket of the feeder. Note: do not apply the lubricant to the face of the feeder, otherwise signal transmission will be affected. Verify that the polarization direction of the hybrid coupler is the same as the polarization direction of the antenna. Slowly feed the antenna interface of the hybrid coupler into the antenna feeder until the 4 latches on the hybrid coupler engage with the 4 hooks on the antenna. Close the 4 latches cornerwise. Screw in the 4 captive screws about 70% on the hybrid coupler and use the hex key wrench to tighten them cornerwise. Chapter 3. Installing the ODU for a 1+1 protection system. First, verify that the type of the ODU is compliant with the design. Apply an appropriate lubricant to the gasket of the feeder of the hybrid coupler. Note: do not apply the lubricant to the face of the feeder, otherwise signal transmission will be affected. Ensure that the polarization direction of the hybrid coupler is the same as that of the ODU. Slowly feed the antenna feeder of the hybrid coupler into the antenna interface of the ODU until the 4 latches on the hybrid coupler engage with the 4 hooks on the ODU. Close the 4 latches cornerwise. Repeat the operations to install the other ODU. Note: ensure that the IF interface on the ODU faces left or right, downwards, after the ODU installation is complete. The main ODU must be installed on the main interface of the hybrid coupler, and the standby ODU must be installed on the standby interface of the hybrid coupler. Ground the ODUs after the ODU installation is complete. Remove the nut on the grounding bolt of one ODU. Connect the OT terminal of the grounding cable to the grounding bolt and tighten the nut. Determine and create the length of the grounding cable according to the location of the grounding point. Strip a certain length off the insulating layer and expose the conductor. Glide an OT terminal over the conductor and ensure that the cross-section of the conductor is level with the end surface of the OT terminal. Use crimping pliers to compress the terminal to ensure a reliable connection. Finally, properly fasten the grounding cable to the iron tower or the grounding bar and tighten the nut. Remove the rust and anti-rust paint from the iron tower when fixing the grounding clip. Chapter 4. Installing the IF cable. 1. Making connectors for the IF cable. Required tools are wrench, snap-off knife, diagonal pliers, and file. Glide a lock nut over the IF cable. Use the snap-off knife to strip 2 cm cable sheath. Be careful not to damage the shielding layer. Neaten the shielding layer and pass it through a clamp, clamp 1. Fold back the shielding layer. Glide another clamp, clamp 2, over the cable and fix clamp 2 between the insulating layer and the shielding layer. Trim off the surplus shielding layer and leave only about 4 mm to be pressed on clamp 1. Strip off the wide insulating layer to make the cross-section of the insulating layer level with clamp 2 and expose the core wire. Cut the excess length of the exposed core wire and leave about 6 mm. Then use a file to taper the edge of the core wire and clean out the metal fillings. Fit the cable head into the connector shell and tighten the lock nut. Specifically, use the solid wrench to fix the connector shell and use the adjustable wrench to rotate and tighten the lock nut. Check if there is a short circuit or an open circuit in the IF cable. If the IF cable functions normally, it indicates that the making of the IF cable connector is successful. Note: rotate the lock nut instead of the connector shell to tighten the connector. Use proper force to rotate the lock nut to prevent damaging the outer covering of the connector. 2. Hoisting and connecting the IF cable. Determine and create a length of the IF cable with a surplus of 3 to 5 meters based on the designed distance between the IDU and the ODU. Before the IF cables are hoisted, take proper protection measures and dust-proof measures for the IF cable connectors. Label the cables so that the main cables can be distinguished from the standby cables, and there is no confusion when IF cables are connected. Bind the IF cable with a cable tie. Do not bind the IF cable at the connector to prevent the connector from being damaged during the hoisting. Also ensure that the IF cable is not bent or twisted during the hoisting. Use cable ties to fix the IF cable to the tower after the hoisting is complete. Then connect one end of the IF cable to the IF connector of the ODU. Rotate the connector clockwise. You can use a wrench to gently tighten the connecting nut. Take waterproof measures for the part of the cable below the ODU and the part of the cable just outside the IDU room to prevent rainwater from entering the equipment along the cable and causing an equipment failure. Note: the IF cable is used to transmit IF signals and supply power to the ODU. Therefore, before installing the IF cable to the IF connector of the ODU, ensure that the power is turned off. Otherwise, a short circuit occurs and damages the equipment. Do not twist the head or connector of the IF cable. Otherwise, the inner shielding layer will be damaged, which may cause a short circuit and thus damage the equipment. Before routing the IF cable, tidy up the cable. Pay attention not to twist the cable connector. You need to coil the IF cable after the waterproof curve below the ODU into a loop with a diameter of 0.6 meter and bind the loop to the pole in case the antenna is adjusted. 3. Waterproofing the IF cable. After the IF cable is installed, you need to take waterproof measures. Specifically, wrap the adhesive waterproof tape around the connection between the IF interface of the ODU and the IF cable. Next, we will explain how to waterproof the connection between the IF cable and the ODU. First, spirally wrap a layer of PVC tape around the connector. Then, unwrap the adhesive waterproof tape and strip off the release paper. Attach one end of the tape to the cable 2 to 5 cm away from the connector. Ensure that the adhesive layer is facing inwards. Stretch the tape to evenly shorten the width to 3/4 to half of the original. Maintain the width in the following operations. Use the tape to spirally wrap the cable upwards starting from 5 cm below the connector, with the outer layer covering half area of the inner layer. After the tape wraps to the top of the connector, wrap the cable spirally downwards by using the same method described earlier. After the tape wraps to 2 to 5 cm below the connector, wrap the cable spirally upwards by using the same method described earlier. Make sure that you have wrapped the cable with 3 layers of waterproof tape. Squeeze the in-wrapped cable to force out the air between the layers so that the 3 layers are fully and tightly glued to one another. Following the same method, wrap 3 layers of PVC tape around the in-wrapped cable. Ensure that you maintain a proper stretching strength during the wrapping so that the width of the PVC tape remain 3/4 to half of the original. Finally, use cable ties to tightly bind the 2 ends of the PVC tape to prevent the PVC tape from becoming loose. Affix the correct waterproof label to the IF cable. 4. Grounding and fixing the IF cable. The IF cable is a type of coaxial cable used to connect the IDU and the ODU. The IF cable transmits IF signal and supplies power to the ODU. As most parts of the IF cable is routed outdoor environment can greatly affect the performance of the IF cable. Therefore, the following requirements are proposed for the grounding and fixing of the IF cable. 1. One IF cable should have at least 3 grounding points, which are close to the ODU, close to the entrance of the equipment room, and at the middle of the IF cable. The middle grounding points should be evenly distributed on the cable. How to ground the IF cable. Strip a length of outer sheath off the IF cable according to the width of the grounding clip. Fix the grounding clip to the shielding layer of the IF cable by securing the screws. Following the same waterproofing method as described previously, take waterproof measures. After the waterproofing operation is complete, fix the other end of the grounding clip to the grounding bar of the iron tower or directly to the iron tower. Note: do not ground the IF cable at the point where the cable is bent. Remove the rust and anti-rust paint from the iron tower when fixing and grounding the clip. 2. Because the IF cable needs to be routed from the top of the tower into the equipment room, the IF cable is always long. The wind outdoor can cause the cable to shake or even become loose. Therefore, you need to fix the IF cable properly. It is recommended that you use cable ties to fix the IF cable to the tower. Use 1 cable tie for every 1 meter of the cable. Note: use cable ties to fix the IF cable at the 2 ends of the waterproof curve. Use cable ties to fix the IF cable 20 cm above and below the grounding point.
इसका क्या था? अच्छा 9 10 what do you want to know about the see the LCD connect start the computer भैया भैया इतने देर से बैठे बात बात इतना इतना चलो इतना चलो अस्सलाम वालेकुम जी टेम्परेचर जी एसी बंद है अपना इसमें कैमरे काफी सारे हैं हीट तो होना ही है क्या करें वो कोई ये थे यमनी वगैरह थे सऊदी थे या यमनी थे पता नहीं साइड अप है अब हम जा सकते हैं चलो ठीक है जाओ ओके अब एनी लागन करो दोनों को इकट्ठे सेलेक्ट करो और एनी लागन करो सबसे ऊपर क्लिक करो इधर पासवर्ड लिखो PASSWORD पासवर्ड अब हो जाएगा लॉगिन और लेकर लॉगिन करने की चीज़ को ये खुल गया इसका मेन पेज कॉन्फ़िगरेशन लिंक कॉन्फ़िगरेशन ऑडियो एंड पाइथन इधर जो भी करना है इसका ना इधर करते हैं नहीं पावर चेंज करना है फ्रीक्वेंसी दी पावर दी सब कुछ दिया और हाँ अप्लाई क्वेरी अप्लाई क्वेरी मेंटेनेंस ऑन करना नहीं पड़ता इसमें कुछ ड्रैग मैंने अभी इधर करो ये फर्स्ट पेज है इस पे सब कुछ करते हैं यस आई कट यू क्रॉस कनेक्शन आधा क्रॉस कनेक्शन वाहद पीजी वाहद ही दिया हुआ है क्रिएट पॉइंट नंबर आया कार्ड है 4 नंबर PH1 है क्या क्या करो एनी एट्रीब्यूट यहाँ गेटवे आईडी वगैरह जो इसकी साइड आईडी है वो डालनी है नेम है इसका नेम नहीं डाला हुआ हाँ ये नाम डालना उसके बाद अप्लाई से ओके कर देना अस्सलाम भाई जी हाँ रिस्टार्ट किया वो ही ना हाई टेम्परेचर था जो उसके बाद ऑटोमेटिकली क्लियर हो गया टीवी क्लोज हो गई है ना हमारी चलो बात चलता है license management quick configuration link configuration port protection slot सबसे पहले नई कॉन्फ़िगरेशन करते हैं ना इस सब पे ना कोई निशान नहीं होता ये कार्ड डाल के बाद में ऐड लीगल बोर्ड करना पड़ता है सबको क्लिक कर एक्सेप्ट कर लेता है जितने भी इसके साथ कनेक्ट है ना एक टाइम सब वन बाई वन भी होता है एक टाइम भी कर सकते हो other alarm systems. Major alarm is coming, ghost streets, critical ROF, LOF, loss of frame ID का alarm आ रहा है. तो जा ये कसम से वो जो ड्रॉप है ना
ओ तंग गया है
तंग है ये बस ऊपर जा रहा है कुछ नहीं यार ऐसा सुकून में है वो ज्यादा आओ
पठान ऊपर से चलाने लगा
इसको मार दीजिए
ओ अमजद अमजद बाहर आ जल्दी बाहर आओ भाग गया
ऊपर एंगल में जा नहीं सकते उधर से
यार रोब नू फड़ लेना सी कुछ हाँ आंदे और रोप वाला रोप पा दूसरा सेफ्टी बेल्ट वाला रोप पा इसके गिर्द ओए सेफ्टी बेल्ट वाला रोप फेंक ले चल पीछे खींच सेफ्टी खींच इधर खींच हाँ खींच खींच आने दे जोर से चल ऊपर ले जा ऊपर जल्दी छोड़ दे छोड़ दे जल्दी छोड़ ऊपर ऊपर वाले को देख कितना इजी आ रहा आने दे स्पीड से आने दे ओ हाथ क्यों मारा तू मामा हिर दिया छड़ टावर गाड़ू वीडियो बनाई थल्ले ओ पीछा खींच के रख गुजरा थोड़ा जा टड के भी खा बस कर पुलिस पहुंचे भाई बस बेल्ट खोल चल आंदा थले ओ तेरी मां